Okay, so this is the screencast of Ricky Sparks' speed car for physics. This is evidence of me building the car, and this is evidence that the car is built, or the finished product. Okay, so to find the energy stored in the mousetrap spring, I spelled mousetrap wrong, I used the torsion wheel, and then this is the data I found. So at angle 30, I found that the force of the spring was 3.0 newtons. At 60 degrees, the force was 3.8 newtons. At 90 degrees, the force was 4.3 newtons. At 130 degrees, the force was 5 newtons. At 160 degrees, the force was 5.7 newtons. And at 180 degrees, the force was 6.1 newtons. So the max elastic energy is at 180 degrees, and that's 6.1 newtons. Okay, now we can look at the position versus time graph for my speed car. And I went from right to left, so the position is negative. I probably could have flipped that, but I didn't. So right here, you can see that it's concave down, which means it's accelerating. And then all right here, it's decelerating because I got all my energy was released right here, all my elastic energy, and after that, it was just decelerating the whole time. Okay, so to find the total displacement of my speed car, I took the integral of velocity, and I got 4.407, which should be in meters. Oh yeah, seconds times meters per second. The seconds would cancel out. So 4.407 meters, which looks about right because if we take this position graph, this looks to be about 4.4. So the total displacement was 4.4 meters. Okay, so to find the mass of the car, I used the force sensor, and I got 0.83 newtons. And to find kilograms, I divided by 9.8, and that makes for mass. So my mass is 0.085 kilograms. Okay, and to find the max velocity and kinetic energy, I set the elastic energy equal to the kinetic energy, and we know that the elastic energy equation is 1/2 k delta x squared, and the kinetic energy equation is 1/2 mass times velocity squared. And whoops. Okay, so the elastic energy, the greatest elastic energy my car had was 0.328 joules. And to find the kinetic energy, I put my mass as 0.085 kilograms, which we found here, times velocity squared, and I solved for v, and I got v is equal to 2.778. So that was my max velocity, and my max kinetic energy was 0.32798 joules. And we know that's the max because this was the max elastic energy, so if we set it equal to the kinetic energy, that's the max kinetic energy. Using the position time graph, we can see that the max acceleration was about here, because that's when the slope would be, or it's concave up the most, and the max deceleration is, well, this whole thing. But we can tell here, using the velocity graph, that right about here would be the max acceleration, because acceleration is the slope of, or velocity is the slope of, no, acceleration is the slope of velocity. And this is where it's graded. Yes, acceleration is the slope of velocity, and this is right about where the slope of velocity is the greatest. And then the slope of velocity would be like the least, about right here. So greatest deceleration is here, and the greatest acceleration is right here. During acceleration, my car has the force of, it has normal force, weight pushing down, friction, and the force of the mousetrap. And during deceleration, it has normal force, weight pushing down, the force of friction is greater, and the force of the mousetrap still. And some of the forces with the mass times acceleration, which is this right here. So it would accelerate, and some of the forces here would be this in the negative direction, so it would be decelerating. I used VPython to create a simulation or a program of my mousetrap car accelerating and decelerating. So for the velocity, initial velocity is 0. For the acceleration, I put 3.314, and the deceleration is negative 0.47. So when we run it, it'll hit F5, now F5. Alright, so the car speeds up pretty rapidly, and then it slows down, and it doesn't go too far, just like my actual car. This is my energy flow diagram. We have 3 points in time. The beginning, when the kinetic energy is at 0, and the elastic energy is max when the spring is all the way back. And the elastic energy is about 0.35 joules. This is the elastic energy equation. And there's no EDIS here because it's still going to it moving. EK is max. So this is from still to moving. There's no EDIS. It accelerates. Kinetic energy is 0.35 because the energy just moves from elastic to kinetic. And this is the equation. And then from the max kinetic energy to stopped all the way at the end, there will be no energy at the end. So all the energy is lost, is dissipated through friction and air resistance, but probably not too much air resistance because the cars are so small. So the system in both this car, and from the max elastic energy to max kinetic energy, there's no energy dissipated. And then from the max kinetic energy to stop, or to when the car stopped, all the energy is lost. And that concludes my mousetrap speed car.